given such that the difference of its distance from two fixed points is constant. The fixed points are called foci, and the constant distance is called the length of the transverse axis.
Before we proceed to the examples of hyperbola, we will discuss the derivation of the formula. This is an example of hyperbola. The absolute value of the difference of the distance 1 and the distance 2 is constant. We know that we're finding the distance, so we're going to use the distance formula. We're going to assign the variables x sub 2, x sub 1, y sub 2, and y sub 1. We're looking for two distances, so we will use two distance formula. Now we're going to assign the variables. Now that we assign the variables, we're going to substitute the variables. And we will get the square root of quantity x plus c squared plus y minus 0 quantity squared minus the square root of x minus c quantity squared plus y minus 0 quantity squared equals 2a. Simplifying the given, the 0 will be eliminated and we will square the both sides. And we will get x minus c quantity squared plus y squared equals 4a squared minus 4a square root of x plus c quantity squared y plus y squared plus x minus c squared plus y squared. Now we will expand the expandable terms. The x minus c squared from both sides will be like this. Like terms from the opposite side will be cancelled out. After we cancel the like terms, we will combine like terms. And we will get this formula. We can see that the four terms are divisible by 4. We will simplify the given and we will get this. Rearranging the formula, we will get negative a squared minus cx equals negative a square root of x plus c squared plus y squared. Then we will square both sides to eliminate the square root. And now we're going to expand the expandable terms. After that, we're going to distribute the a to the polynomial x squared plus 2xc plus c squared plus y squared. Then we're going to cancel out like terms from different sides. Rearranging the terms, the equation will be like this. And we're going to find the factor of these two polynomial. After we factor this out, we're going to divide both sides by a squared quantity a squared minus c squared. Then simplify. The equation will look like this. The Pythagorean, we will use a Pythagorean theorem. To get the value of a squared minus e squared, we will rearrange the terms. After we rearrange the terms, we will substitute the value of a squared minus c squared to negative b squared. If we simplify the formula will be like this. in deriving the formula of the y-axis of the hyperbola, we will use the same equation but different coordinates. But by following the same process, we'll get the formula y squared over a squared minus x squared over b squared is equals to 1. Now we're going to derive the formula of a hyperbola with a center at h and k. The derivation will be from the standard equation of the hyperbola with a center at 0, 0 or its origin. We're just going to substitute the change of x and the change of y. The change of x, quantity squared over a squared minus change of y, quantity squared over b squared is equals to 1. Substituting the value of change of x and change of y, we can get the equation x minus h, quantity squared over a squared minus y minus k, quantity squared over b squared. Same with y-axis. The hyperbola with the center at h and k. Take note that the a squared is always on the positive side. B squared can be greater than a squared, but a squared can never be negative.
Here's an example of hyperbola parallel to y-axis and the center on its origin. First, we're going to find the value of a and b by finding the square root of a squared and b squared. So, a is equals to 6, then b is equals to 5. So, we're going to find the value of c squared using the Pythagorean theorem. So, the answer will be 7.8. Now, we're going to substitute the value of a, b, and c. So, the vertices will be 0 and positive 6 and 0, negative 6. The value of foci will be 0, positive 7.8 and 0, negative 7.8. And the value of endpoints of the conjugate axis will be positive 5, 0 and negative 5, 0. Now, we're going to find the value of the eccentricity using the formula E is equals to C over A. So the answer will be 1.3. Now that we know the value of the eccentricity, we will be able to find the value of directrix using the formula D is equals to A over. Then, we're going to find the value of asymptote by using the formula y is equals to positive negative a over b x. So, the value of asymptote will be y is equals to positive negative 6 over 5 x. Then, we're going to find the length of the vertex by using the formula of 2 times a. So the value of the vertex will be 12. Then we're going to find the value of the foci by using the formula of 2 times c. So the value of length of the foci will be 15.6. Then the last, we're going to find the value of the conjugate axis by using the formula of 2 times b. So the answer will be 10. So, we're going to find the value of the length of the latus rectum. The formula is 2b squared over 8. So the value of the length of the latus rectum will be 5.56. Now, we're going to find the coordinates of the ELR, or the endpoints of the latus rectum. The formula of the endpoints of the latus rectum will be positive negative b squared over a and positive negative c. So, the value of the endpoints of the latus rectum will be positive negative 4.17 and positive negative 7.8.
For the x-axis, the standard equation is x squared over 25 minus y squared over 100 is equal to 1. A squared is equal to 25. The square root of 25 is 5. B squared is equal to 100. The square root of 100 is 10. For the c squared, we use the Pythagorean theorem. A squared plus b squared, which is 25 plus 100, is equal to 125. The square root of 125 is 11.18. For the vertices, we will substitute positive and negative a0 to 50 and negative 50. For the foci, we will also substitute positive and negative c and 0 to 11.18 and 0 and 11.180. For the endpoints of conjugate axis, we will substitute 0 and positive negative b to 0 and 10 to 0, negative 10. To get the length of the latus rectum, we will substitute 2b squared over a is equal to 40. And for the directrix, we will substitute a squared over c, which is 25 over 11.18 is equal to positive negative 2.1. The distance of the directrix, we use the formula 2 times t is equal to 4.47. For the distance of the foci, we have 2 times c is equal to 22.36. For the distance of the vertex, we use the formula 2 times v is equal to 10. For the length of the conjugate axis, we use the formula 2 times v is equal to 20. For the eccentricity, we will substitute c over a is equal to 11.18 over 5, which is 2.236. For the asymptote, we have y is equal to positive and negative 2x. To find the endpoints of the latus rectum, we use positive and negative c and positive negative b squared over a. For the ELR1, 11.1820 and ELR2, 11.18 negative 20. ELR3, negative 11.18 and 20. ELR4, negative 11.18 and negative 20.
So, for our example for today is when the center is at H and K. So, our standard when the center is at H and K is y plus 2 minus y plus 2 over 9 minus x minus 2 over 16. And for the a squared, remember that a squared is always on the positive side, which is 9. So, a squared is equal to 9 and the square root of 9 is 3. And b squared is 16 and the square root of 16 is 4. And to find the c squared, we will use the Pythagorean theorem, which is 16 plus 9 is equals to 25 and the square root of 25 is 5. To find the center, we will use h and k and substitute it. And the answer will be 2 and negative 2. For the vertices, use h and a and positive and negative k. So the answer will be 2 and 1 and 2 and negative 5. And for the foci, we will use h, k, positive and negative 6, and the answers will be 2 and 3, 2 and negative 7. And for the endpoints of the conjugate axis, we will use h, positive and negative b, and k, and the answers are 6 and negative 2, and negative 2 and negative 2. To find the equation of directrix, we will use the formula k, positive and negative a squared over c, and the answer will be
negative 2, positive and negative 9 over 5. And for the equation of asymptote, we will use its formula y is equals to a positive and negative a x minus h over b. And the answer will be negative 2 positive and negative 3 x minus 2 over 4. To find the distance of the vertices, we will use 2a. Let's just substitute 2a, which is 3. So 2 times 3 is equals to 6. So the distance of foci, 2 times c is equals to 10. And for the distance of the conjugate axis, you will just substitute 2 times b is equals to 8. To find the endpoints of the telerecta, we will use positive and negative c and positive and negative b squared over 8. So our DLR1 is 7.33 and 3. For the DLR2, negative 3.33 and 3. For the DLR3 is 7.33 and negative 7. And for the DLR4, negative 3.33